Assalamu alaikum class 6. Hope you all are fine. This is your computer class and we are going to start our first chapter, the evolution of computers. Open your book, page number 3. Our today's topic is that how computer process data. A computer receives input in the form of raw data through an input device. It processes data by changing it into an understandable form. Processed data is called information. The computer then presents information to end users. This information is called output. Let's see how computers have changed over time. The abacus. It is the earliest calculator which uses beads that are moved across wires or strings to add and subtract numbers. It has helped to achieve accuracy in calculations. Napier booms. In 1617, John Napier invented a system called Napier booms. It consisted of a set of rods with numbers written on them. It could be used to multiply and divide numbers. Next is the Pascaline. In 1642, Blaise Pascal developed the first mechanical calculator called the Pascaline. Instead of beads or rods, it was operated by wheels and could add and subtract numbers. The Leibniz calculator. Gottfried Leibniz invented the Leibniz calculator in 1694. It used wheels to add and subtract, but it could also multiply and divide numbers. Next is the punch card. It is a strip of card with holes punched in it. Punch cards were developed by Joseph Jacquard in 1801 to control a weaving loom. Later, punch cards were used to program or give instructions to computer. Charles Babbage. It is also called the father of modern digital computer. In the 19th century, he designed two machines. First is difference engine and second is analytical engine. Babbage used punch card to give instructions to the analytical engine. Hermann Hollerith. In 1890, Hermann Hollerith developed a tabulating machine. He used punch cards to give instructions to it and to store data. This introduced the concept of storage devices into the evolution of computer. Next is the electronic computer. In the 20th century, computers were using electric power to process information. These computers developed more rapidly than earlier computing devices. Computers have been classified into generations. Let's look at how each generation contributed to the development of modern digital computer. The first generation computer. The computers of first generation used vacuum tubes. A vacuum tube consists of a glass bulb and a wire. The wire carries data in the form of electronic signals. ENIAC, electronic numerical integrator and calculator. It was the first generation computer. It contained nearly 19,000 vacuum tubes and weighed about 27 tons. The second generation computer. It used transistors. A transistor can carry much more electric current than a vacuum tube. These computers were faster and smaller. They were also cheaper, more reliable, and produced less heat. The third generation computer. The third generation computer used integrated circuits called ICs. An integrated circuit or IC is as small as a transistor, but it can work as fast as thousands of them. Computer became smaller, faster, and cheaper. They used less electricity and make fewer mistakes. The fourth generation computer are based on microprocessor. A microprocessor consists of a small silicon chip on which thousands of circuits are placed or printed. They are smaller, portable, reliable, and cheaper. They use less electricity and produce less heat. The fifth generation computer used artificial intelligence and are still undergoing development. Fifth generation can be used voice for processing information and understanding the user conversational language used in the everyday life. Our next topic is types of computing devices. So we have two types of computing devices, that is analog and digital. First is analog device. So devices that process analog data are called analog devices. Analog data has continuous value. It is used for measuring quantities like length, weight, and time. Analog clocks, weighing scales, and thermometers are analog devices. Next is digital devices. So it processes digital data. Digital data is discrete. It is used to count things or measure things in steps. Digital devices do not give reading on a continuous scale. Examples are digital clocks, traffic lights, calculators, and digital thermometers. Our next topic is that computers according to size. So first we will discuss about supercomputers. So supercomputers are the most complex computer. They use many advanced design techniques and have very high computing capacities and speeds. Supercomputer users are people who need to process complex data. Okay, so our next topic is the mainframe computer. Mainframe computers are large and expensive. They have powerful processors and very large memories. They are used in large banks, airlines, and universities. Hundreds of users can work at a mainframe computer at the same time. The mini computer. Mini computers are smaller and cheaper than mainframe computers. They have less processing power. These computers are used in large sized businesses, colleges, banks, and libraries. The microcomputer. These computers are smaller and cheaper than mini computers. They are used by using single user and are called desktop computers or personal computers, PCs. So there are three types of microcomputers. First is laptop computers, second is smartphone and tablets, and third one is embedded computers. Okay, our last topic is places where computers are used. So there are many places where computers are used. For example, in banks use computers to keep track of their clients' money. Businesses, small and large businesses use word processors, databases, and spreadsheets. Factories use computerized robots to assemble items such as cars and televisions. Entertainment companies use computers to create cartoons and special effects on TV and in films. Advertising companies use computer graphics to create colorful advertisements for TV, magazines, and newspapers. Medical professionals use computer for research, treatment, and producing X-rays. And law enforcement agencies use computer to track down criminals. Okay. So this is our today's lecture. Hopefully you understand it. Thank you.